First, the antenna receives the signal, which is then passed on to the RF filter, which takes out just the FM spectrum from the signal. It then goes to the mixer and the oscillator combo. The mixer takes the sum and difference of the two input signals from the FM band and the oscillator. The oscillator is basically used to change the output from the mixer. Then it goes to the filter, which filters out the specific frequency that we want, and it is amplified. The demodulator converts the encoded info to audio, which is then further amplified and goes onto the speaker, after which we can hear the radio sound.
So this is a basic block diagram of an FM receiver, and first we are going to talk about RF and IF filters. They both share the same circuit, that is of a band pass filter. The band pass filter looks something like this. It has in series a high pass filter and a low pass filter. High pass filter allows only the waves which have frequency higher than a certain frequency. Let's call it F2. And the low pass filter allows frequencies which are lower than a certain frequencies. Let's call it F1. So if we combine them in series, in output we will obtain the waves which have frequencies in between F1 and F2. Now we will consider the RF mixer. In our case, it takes the RF signal and the signal from the local oscillator and gives the difference of the two. The circuit of the RF mixer looks something like this. If we consider the positive cycle of both RF and LO, then we can see the polarities are as shown in the figure, and the output will be RF minus LO, considering RF is greater than LO, and similar is for the negative cycle case. Next we will see local oscillator. Here we use it to produce variable high frequency waves to input in the RF mixer. One of such oscillators is Colpitt's oscillator. When the power supply is switched on, C1 and C2 starts charging. After they are fully charged, they start discharging through L, and this leads to damped harmonic oscillations. This gives rise to an AC voltage across C1 and C2. The energy lost during damping is compensated by the amplifying effect of the transistor, and thus oscillations are sustained. Next we will see the demodulator. So when we input an unmodulated wave in the circuit, we obtain an intermediate wave which looks something like this. You can see the parts where frequency is low gets attenuated due to the capacitor, as its impedance goes very high, and the parts where the frequency is very high does not get attenuated that much because the impedance is very low. The final output is obtained with the help of the envelope detector, which comprises of D1 and C3. So now we will see an FM receiver made using these components. So this is the circuit. So the signal enters from here, and then from the wide range of frequencies that the antenna catch, it filters out the frequencies which are in the radio range from this part. This is the RF filter. Then it amplifies them using a transistor, which is this. Then the signal goes into the RF mixer. This is the RF signal which comes from here. And this is the LO signal which comes from the local oscillator. The output signal, which is RF minus LO, goes out from here, and from this the IF filter filters out the intermediate frequency. This is then demodulated using the circuit explained just before this, and the final output is converted into audio using this IC1 circuit.
Now the question is how to change the channel in a FM radio. So this is the circuit of a local oscillator. It consists of two transistors, an inductor and a capacitor with variable capacitance. The local oscillator generates a wave of particular frequency which depends on the capacitance of the capacitor. When the difference in frequencies of the radio wave and the local oscillator becomes equal to the frequency of the IF filter, it can pass through the IF filter, and hence the channel can be changed.